morning, good evening, good afternoon, wherever you're in the world. Thank you for joining us again for another session of Pandemic Punditry is putting the planet on a pandemic diet. We are thrilled, honored, and quite excited actually to talk to Esh. I'm going to say Esh, but his full name is Eshchar Ben-Shitrit. If I'm sure I mispronounced his first name. But Esh has joined us from Israel today, where his company has done a very exciting sort of combined two very exciting technologies, cutting edge technologies, 3D printing, and of course, smart protein, plant-based protein, and made this wonderful thing called a 3D printed steak. And he'll talk a little bit more about that. But welcome to the program, Eshchar. Esh.
Thank you. I'm also really happy to be here and to give a fresh insight about what we're doing, why, and especially why is it relevant to this age and time with COVID and without COVID.
Yeah, so I'm curious, just to sort of step back and ask you, you're a law clerk to the Supreme Court of Israel, a lawyer, MBA in finance. How did you end up in this business of sort of plant-based foods where you're combining two very sort of unique and cutting edge, almost bleeding edge technologies to produce something very exciting? What was that inspiration? Where did the inspiration come for that?
First, it's a funny question to ask because I don't think there is a path in life that leads anybody to work on 3D printed steaks, right? There's nobody that you ask, it makes a lot of sense that you found yourself 3D printing steak. But actually, I like to think, or maybe it's what I tell myself to sleep at night, that my path actually led me naturally to become the right person to do what I'm doing. I did study law, but I was drawn to technology from a very early age. And I found myself doing things like most of us. I find myself from one job to another, from one opportunity to another, doing things that I thought were exciting. I had a good career and I was working in the Supreme Court and then going to HP to become a product manager. Then I was offered to become a VP product and marketing for a high-tech company. And I thought it makes a lot of sense. But deep inside, I always asked myself, is this what I was meant to do? Is this what I'm going to spend my life, my entire career doing? And of course, the answer is no, because I didn't choose to do it. Something led me to do it. And I decided quite some time ago, before founding the company and before thinking about 3D printing meat, that I need to choose what I want to do, literally choose. And to find what many people say, and maybe they're lying to themselves saying, I need to find a real passion. Something that I say, wow, I want to wake up every day and I want to do it for the next decade at least. And then many things happened in life that are related to the fact that I stopped eating meat, it's just an anecdote. It was an anecdote at that point of time. I was that guy who loved meat, but stopped eating meat. That was one. And one other thing, I became quite obsessed with something that is called 3D printed food, because I read a lot about it. It's been around for over a decade. If you Google 3D printed food, you see things from over a decade ago. And I was really surprised by the contrast in the potential. When you read what 3D printed food can be and what it actually is, I became a little bit obsessed about that. And then one day, I stepped out of the shower and I told my wife, I have an idea. We can connect alternatives to meat with 3D printed food and do it right. And it's going to be amazing and it's going to be big. And that was a very naive idea at that point of time. But still, a lot of the things we are working on now on the technology came from the questions that this idea brought about. And it's related to my professional experience and my personal experience. And when you talk with people that know me and you say, Eshchar is 3D printed steaks, some people actually say it makes sense. If somebody should 3D print meat, it's probably me. And I've been into this for 2.5 years now. And it's been the most intense, most difficult time in my professional career. But there isn't a single day that I think I have something else to do. And it's really important. When you find something like that, the strength you can bring about, what you can achieve, is dramatically different than a normal career.
Absolutely. So this Archimedes moment, coming out of the shower, the light bulbs going off, right? And then, you have this sort of purpose, I guess, now defined for the next 10 years, as you said, to do this. So, did you sort of have you said you love technology, but had you sort of done any 3D printing stuff before, or you said, okay, now I got to go find teach myself this, or find people who can do this? Or how did that process sort of work?
actually, in my career before what I did, I was a product manager, and I saw a very unique capability. I'm not a technology person. I'm not an engineer, and I'm not a scientist. But there is this part in technology where you need somebody to ask questions and help amazing engineers and amazing technologists develop something. And when I started working in HP, what they teach you, basically, I'm simplifying it, they tell you, you can develop anything in the world. Any technology is possible, but you need to know why you're doing that and what you're trying to achieve. And that's the role of a product manager. And I saw in very technical fields that the ability to define a question or a problem and what needs to be solved allows people that know technology to develop technology. And I saw it happening really fast in massive projects. And I said, this is a discipline. How you look at the problem, you look at a technical problem, and you say, this is a possible solution. Okay, this will give you an answer. Now, chemists, engineers, software guys develop this solution. And I discovered many people know that work for large technology company, that finding technological solutions is very, very easy once you define the problem. Once you sit with a customer or you sit with people that deal with something day in and day out, and you understand what they're doing. And in many cases, you will discover they have been doing the same thing for 30 years. Why? Because that's what they were taught to do. Yeah. And then you don't know how, but you said, what if you can do it in a different way? Now let's go and develop it. So I didn't have technology background, but I knew that once you apply this discipline or methodology, even things like that are wide, like 3D printed meat, you can break them down to what do you need to work on in the food science, what do you need to work on the mechanical engineering, what the software needs to do. And then you know how to find the right people to do it. And the good technological ideas in the company, they didn't come from me. Actually, the people in technology needed to explain to me why my ideas are stupid. But finding the people or breaking down the problems to work on technology, this is something I still think I know how to do quite well. And my co-founder, who's also a product manager, is really good in that. And both of us, we come from economics, business perspective, but we have this way of thinking of breaking down the problem, understanding the root causes of things, and working side by side with brilliant people.
So if I was to sort of ask you, I mean, we've circulated a few articles about you, and there are some pictures and videos and all that on the web that we've some sort of tagged, and hopefully people have seen that. But if you were to break it down, so you have, I mean, a difference in your approach to a plant. I mean, most of the plant-based stuff tends to be either sort of strips or mince, mostly, especially on the meat side. So this is actually physically looks like a porterhouse steak or a sirloin strip, right? I mean, it's a meaty, something you can chew into, bite into, cut into. So just maybe in a sort of to talk us through maybe how it's done. So you have these fats, blood, whatever come into a 3D printer. So if you, I mean, I'm not doing it justice, but if you could sort of explain how that works, that would be interesting, I think, just before we get into other questions.
Sure. Just one level below that. Essentially, when you look today on how we consume meat, we have proteins and we have fat and we have water there. And we have a technology to convert ingredients that are found in nature to meat. That's the animal, that's the cow. Oh. The cow, through its lifespan, creates meat for us. It's a factory that takes building blocks and it creates meat for us. And the meat is so amazing because it has the lifespan of the animal. The movement of the muscle, what the cow ate, the air it breathes, the water it drinks, everything comes to the end to our plate. And this is a very unique method of making food because you have a living creature doing it in cows for 2 years. And the existing food technology know how to find proteins. You can take the same proteins from soy and pea. And we know how to take fats that are lipids and have something that is very similar to that. But how do you make this into meat? How do you make this into something that when you bite through it has this rich, tasty, juicy experience? This is something that the food industry, the traditional food industry is not so good at. Things like making a hamburger are quite simple. You can take those ingredients and you mix them together and you have roughly a similar experience. Mm-hmm. But what happens when you want to go to a steak or a stew? This is something that food technology do not know how to do. This is a very, very complicated food product. And we do not eat today complicated food products. And we started by saying, how can you make the texture of meat? How can you make not the flavor, but the flavor delivery system of meat? How can you create the mouthfeel, the juiciness, all this experience? You need to create a very, very, very sophisticated food product. And our 3D printer, in a sense, again, simplifying, is a robot that can make very complicated food fast, which is important because you need to make it fast. So, it has to be big. If it's not 300 grams, it's not meat. You can buy through. And the way we do it is essentially we have quite a simple form of making formulations. So we take proteins, and we know these proteins have the potential to get the texture of fibers of muscle. Okay, but they don't have, it's a paste. If you eat it as is, it's just a paste. It's a paste with protein, it has some colors in it, it has some flavors, but it's not meat. Then we take fat, we take coconut fat and some other fats, and they have the same fatty acid profile and same element like animal fat. If you bite through it, it's more like margarine. Then we have blood. Blood is a gel. It has the color of blood, deep red. It has some molecules that have the potential to give you a flavor. If you eat that, it's like a jelly of meat. If you mix everything together, you have nothing. This is what's amazing. If you just mix it, it's not a hamburger, it's not mincemeat, it's not a steak. Then we put all of those on a machine. It's quite a big machine. It's like a refrigerator. It's not a small desktop machine. And then we have a very complex system of taking each material separately, undergoing some processes that are our intellectual property, and then laying it all down in a very small resolution, 1 millimeter resolution, in a certain position. And then we do it again and again and again and again and again, millions of times, literally millions of times, to decide how the product is going to look like. And then you have a product that we define in each area. Is it going to be muscle, fat, or blood? Is it going to have this texture or that texture? The one next to it is going to be something different. The one next to it is going to be something different. A capability that no man-made food can do. You cannot do it in your kitchen, but also traditional food technologies cannot do. And this is something quite amazing because the food industry identifies the potential of what we are doing. Nobody ever did it. We are the first one to do it. And when you look at it from a technological perspective, you understand why this gives you a better texture, a better flavor, a better mouthfeel. But when you put our meat in your mouth from very early days, you don't say, wow, this really reminds me of meat. You say, this is meat. Because we can trigger in your brain some of the clues, some of the mechanism that you never had in plant-based meat. Never. Even the best plant-based meat you ever had, maybe they're okay with some elements. We are okay, we're not perfect with everything. We tick all the boxes that your brain identified this as something coming out of a dead animal only. And this is a unique capability that now we are dealing much more on how to scale up. Because the challenge of what we're trying to achieve is not a technological experiment, how we make a very complicated food product, but actually how we bring you people in India, people all over the world, meat products that they like. And they say, this is good meat. I can eat it as a replacement to the meat that I have today. And it happens to be plant-based. It happens to be much more sustainable and more healthy, but the goal is to do it at scale. And the scaling up of 3D printed food is by itself a technological challenge. And we are doing that by taking out some of the difficulties of 3D printing, like being obsessed with resolution, being obsessed with flexibility, which we would love to have, but they are slowing us down, and the need to do something that day in and day out people can eat in large scale. And if you look at the
refrigerator-sized machine, how many kilograms of meat? I heard a couple of thousand, right? I mean, it's a lot of meat it produces.
In its lifespan, yeah, but in an hour, 10 kilogram an hour.
10 kilograms an hour, okay.
Yeah, in a day, it's roughly the same output you get from a cow in 2 years. Because a cow, our machine working 24/7 does 250 kilos a day.
Okay.
And a cow, when you slaughter it it depends on the size, from 700 kilos, you have about 40% yield, which is roughly the same. But the machine is not a single day operation. It's a mini factory. And today we have 4 machines working side by side. And now we're placing more and more machines. And in the future, in the field, we'll have more and more machines.
Of course. Of course. You're muted. You're muted, Karthika. Thank you.
One of the things, thanks, Lavi. One of the things that struck me when you were talking about the meat and the steak was that you said a lot of people can, have the same flavor and you could trigger the same response in the brain. But part of cooking the steak is that it could be medium rare, well done. Is that all possible as well with the 3D printed redefined meat?
Yeah, it's much more challenging because remember that a cow developed through evolution and at least 10,000 years of being domesticated. And we cook meat the way we cook meat because meat is really good in these cooking properties. Of course, even in our product, if you cook it more, it can become less juicy because it has moisture that is released. We were optimizing it to potentially be everything that meat can do. And we believe this is possible. Currently, it's not the perfect steak that you can cook it just as is, because we have some tension. In each technology, you have tension. Mm-hmm. What do you want to achieve? Do you want to achieve really good texture or versatility in cooking? So today we are prioritizing texture. Do you want to have something that can be eaten raw? Meat you can eat raw. Many people, and we had a chef here come in and slice our meat to become raw. And I told him it's interesting, but it wasn't designed to do that. So in a sense, when we design today how our meat is going to be operating or perform in certain cooking methods that we already tested. And we know it's really good in some cooking methods and it's really terrible in some other cooking methods. And we don't necessarily want to capture everything at this point of time. But
what is the goal? I mean, is it a medium rare sort of pan fried grilled steak, or what is that sweet spot for you?
So first, there are many golden standards, but it's mostly steak. Okay, not only steak. Okay. And we look at the two main ones. One is tenderloin, fillet steak, and one is ribeye. Because there is a wide difference in juiciness, tenderness, flavor intensity, and fat content in both of those. And we look at something that is medium, because in medium you have this grilly or cooked flavors, but also the bloody, metallic, what you call animalic flavor, and they represent really well meat. And today we are more working on pan searing, because on grill, on open fire, which I love more, I used to eat much more meat on the grill, our meat doesn't perform as it is, but this is more a niche. And of course, once we perfected one, we can go about in perfecting the other one, but we cannot do everything in parallel. It's very important. The vision is really, really aggressive and really big, but we are rooted on the day-to-day. We're rooted on what we are going to serve to our customers and the people that visit us this week. And this needs to be really good. What people sometimes forget is that the technology is not interesting. The food product is what's interesting.
Yeah.
If we can tell a very nice story about technology, and then you eat something which is not tasty, then nobody cares about it. It's not really interesting, the story 3D printing. What we love more is when people taste our meat before they hear about the technology, before they hear about the story, and then they can evaluate it as a food product.
Sure.
So Esh, now that you have the machine, right, you can pretty much print any meat. So does that mean in the future we can see lamb steaks, pork steaks? Is that sort of a natural extension for Redefine Meat?
Definitely. What we are doing now is a whole muscle structure of beef, which is a representative of a mammal. And the muscle structure of mammal, of course, there are differences, pork and beef are quite different, but from a biological perspective or from a shape perspective and a functional perspective, they're very common. There's a lot of similarities. And if you go from beef to pork, you basically change some of the flavor compounds that is found, and of course the color. And essentially the technology can do it. We have no doubt, and we also demonstrated that. The thing is that we are trying to do something that is good for this planet. And in order to do it, we need to become a company. It's not enough to have technology. And if we capture market share and if we grow just by doing the beef products, the market potential is so big. And again, this is based a little bit on my background and past experiences. It's very difficult for a company trying to do what we're doing, developing technology, scaling up a business, becoming international, to do it without focus. And beef is the real representative of what is wrong with the meat industry and with the food industry. And it's not the most consumed meat around the world, but it's the most polluting and the biggest in terms of value. And there is the biggest difference between the quality of the products that come from an animal and the alternatives. So we can even do chicken, but we don't feel that our technology is needed to do chicken, and the market is so big. It's true that when you look at some markets, like in Asia, beef is less consumed. But when you look at the USA and Europe and the markets that we are targeting, even in Asia, the beef industry is big enough and the potential is big enough. And once we establish ourselves in beef, expanding to pork, which I believe is easy. Lamb, by the way, is very easy. Lamb is much closer, but still it's a smaller market potential. And
so interesting. So, so could you, I mean, in the future, see, for example, the Nespresso version of a steak machine sitting on somebody's kitchen counter? I mean, I'm not saying tomorrow, but I'm saying that's possibility, right? I mean, miniaturization and putting things into capsules, and punching out a ribeye versus a sirloin strip. I mean, that should be doable, technically speaking, theoretically speaking, I guess.
Sure. When people live on Mars, I'm sure they'll have a 3D printer of some sort making food from them. The question is if this is really what we need to work on now. I think what we're doing now is laying the infrastructure to do that. But I'm always trying to focus on the problem. We think the problem is cows and the fact that we need to grow cows to have meat, and not how you consume it in your home. Because there are some challenges that we can solve by making meat in your home, but this is not the biggest challenge. On the other hand, developing a consumer product, scaling it down, making it so versatile. What I always say is that the printer in your home needs to print the burger and the bun. If it can only print the burger, it's not enough. And there is no real challenge in making buns. So it's better that you will go to the supermarket, buy 3D printed meat, and walk to your home than us spending time and energies. But definitely at some point of time, what we need all to do is to disconnect food that we consume from the ingredient. You need to grow wheat to make a bun, and you need to grow wheat to feed it to a cow and then slaughter the cow. At some point of time, we will have like this master, many science fiction novelists write about this. We will eat food for nutrition, and we will have technology that covers it really nicely. And then it can be optimized to your needs, and it can be versatile. But this is really, really, we are doing science fiction technology, but we don't want to be science fiction.
Very good point. Very good point.
I have a follow-up question. Esh, I remember you saying you have about 10 3D printers now that are working on printing out these steaks. Does that mean you're going to have a centralized manufacturing plant that's going to supply, or as you move to other countries, are you going to have these 3D printers installed elsewhere?
Today we have 4. I hope that I didn't say 10. We have 4. Actually, we believe that 3D printing can do one important thing, is to replace cows. We believe in that. The challenge and the potential in 3D printing is that it doesn't make sense to scale up production. Because in our case, we don't want the machine to become a much bigger machine. This is traditional way of thinking. We call it an analog way of thinking. You need to have a massive machine that spits out the same product day in and day out. We have a potential to do what is called distributive manufacturing, to take one machine, just one machine, and put it in Switzerland. And then if it's successful, then you add one more machine, 10 other machines, 1,000 machines, and you put them closer to the consumer. You don't put it at their home. You don't need to put it in home, but you can put it in the supermarket. And we built the business model. We built the supply chain model. We built everything based on not how food was made, because meat was made from cows, but how food will be made. And in the future, and we see it in many other industries, people that are not in the food industry, they find it really strange. But the idea of making food closer to you, take Singapore. Singapore doesn't produce its food. So if in Singapore you can go to a mall and in the mall meat is produced, it solves so many problems. It has so much potential. And we developed the machine based on that. The machine is by itself a factory. It has everything that you need in terms of regulation, safety, productivity. But you can very easily put it in a place that you never had food manufacturing, never had meat manufacturing, and being much more efficient in the supply chain. Because remember, in food, you have waste. It's not only meat. Every food that you consume is about 30 to 50% waste.
Yes.
In distributive manufacturing, you don't have waste. So I am a strong believer in distributive manufacturing, especially in the food industry.
I mean, that's a brilliant sort of point on distributive manufacturing. I mean, it really addresses a whole host of issues, right? I mean, that is really the future, right? I mean, people want to consume things, and the pandemic, I mean, clearly shows the fact that you have to transport stuff across oceans and countries and borders is obviously no longer kosher, right? I mean, you have to sort of figure out something that makes sense, and having it, closer to you in a small unit. And I like the fact that you could scale it up by simply just adding another cow equivalent from a 3D printer, right? And that's just that's an amazing model. I mean, I think that makes a lot of sense from what the perspective that you're talking about. Is it possible to sort of potentially license the technology of 3D printing meat for you as a company? I mean, so that, if Beyond wants to put, their burger formulation, Impossible wants to do theirs, essentially you own the technology and the way you produce it, but the source material gives you a different taste, but based on manufacture. Is that something you would consider, or is this, am I just talking completely hat here? I was just thinking.
No, some other companies doing what we're doing might consider that, but okay. We have a different approach and also a different vision, because it's not that you have an industry that is established, 3D printed meat, and we came with a new technology that is slightly better, and now let's license it. What we're doing is a journey, and we're in the early days of the journey. And by not controlling understanding of the market, by not controlling the supply chain, we're missing the real potential. And the real potential is going at one point of time to the Indian market, understanding that in the Indian market, beef alternatives are irrelevant, but we need to create a 3D printed mutton version. Correct. Going back to our lab, developing mutton version, launching it in India, and then taking it to the other parts of the world. So we cannot stop by being a technology company and letting somebody else do the rest. And this is the company that I work for, is a company that was founded in the 70s and is still the most innovative company in its field. Why? Because it's connected to the market. Why? Because it didn't license the technology. It did something much more complicated, but become a global company with deep connection to customers all over the world, with an understanding that in our case, food consumption, when we say meat, many companies in this field say meat. Meat is not one thing. And if you look at beef, the beef that we consume in Israel is very different than the beef that people in our neighboring countries consume. Beef in Switzerland and beef in Italy is a totally different product. And we have the potential to address beef in every form. And then, as you mentioned, go to pork or other food products. But if we just become like a scientific company doing licensing of technology, we cannot do it. We cannot improve, we cannot innovate, we cannot expand. And we think that the potential is not by making our steak today, is by all the steaks that we can make in the next decade and all the things that are not steaks and all the potential we discover while we develop, because we encounter many challenges. And some of the challenges we will only solve 3 years from now. But then we will have a massively new product that we can launch and scale. And in theory, yes, you can license everything and say somebody else will take care of the rest, but we're just getting started. We feel like we're in the first stage. One thing that you did mention around distributive manufacturing in light of COVID, I'm not suggesting that COVID came from meat, but other pandemics might come from meat. And we don't have people traveling, right? We close the borders, people are not traveling, but we still ship dead animals from one country to another. And in cases where this is it's a dead product, but it's a really great place for viruses and other form of pathogens to live. And this is something that it's very hard to stop international export of meat. In our case, we do need to ship the ingredients, but they are shelf stable. They don't have all the pathogens that are associated with meat. And then just locally manufacture. Even if you need to close borders, even if you have problems with international supply chain, manufacturing can be localized, which we also see as something important for the future.
So the ingredients that you're using, you said you mentioned is a shelf stable. So are you mostly the proteins are coming from peas or soy, or is that proprietary?
No, we combine protein, pea and soy, both from a functional perspective. It's also better in a nutritional perspective. We can introduce many protein sources. We just found out that the most common, soy is the most common, and peas is the novel one, they really do a good job in terms of nutrition, in terms of texture, and also availability. Because you need to think also about the ability to source these ingredients. Today, we're coming close to a point where we need the world to grow more pea just for alternative proteins.
Yes.
And if you look at the more novel or new proteins, there's not enough availability in the coming few years. You need an ecosystem to support the growth and the supply chain needs.
Yep, makes perfect sense. Kartika, sorry.
Yeah, no worries. Esh, I remember you mentioned in one of the previous comments that obviously there are different types of cattle, and that you want to be able to provide steak that is, coming from sort of different types of cattle. So in the future, can we see like an equivalent of like a red Angus or like a black Angus, beef? Is that your plan, or?
First, a lot of what we're doing, people say that I'm the most meat-obsessed vegetarian they ever met, is really understand what make people love meat so much. And when you start talking to butchers, you do see there is a huge difference between Wagyu in Japan, Angus in the USA. In Israel, there is this fight, we like to eat Holstein, but in the supermarket, we don't have them. And we try to capture what is similar, what is shared between those breeds. But certainly, if you look at Latin America, if you want profile in terms of texture, in terms of flavor of meat, it needs to be fundamentally different than the US. If you go to Japan, it's a completely different food product. To create most of the differences is quite easy in our technology, because just again, not going too deep, but a Holstein tenderloin is really big, has deep flavor, and has a lot of fat. And this, in a click of a button, we can do, even though that an Angus ribeye is light red, and less fatty, so we can play with the existing technology, existing formulation in a range of product, representing the more intense flavor, the more intense texture, the less intense flavor, the more tough or the more tender. We have this range, and definitely we have something that we print that we call it's more like Wagyu, and something that we print that is more like Angus. And this is actually quite nice about the technology, that the differences between the range in beef, they come without any penalty. No penalty to cost, no penalty to speed, no different ingredients. This is one of the main advantages. And the difference, when people come to us and say, so this is your product, we say, no, this is not the product. This is the product that we printed for you today. And the product tomorrow, the product 1 hour from now can be different just by adjusting the 3D file.
Wow. So what is your sort of go-to-market strategy? I mean, are you ready to sort of make this commercially available soon? I heard that some European chefs or restaurants are going to carry it soon. So I know there's going to be a question that a lot of people ask, where can I eat that? So I'm hoping you can answer that one.
First, until we have more clarity on COVID, the answer is only in Israel, because we're diverting a lot of the efforts in pilot testing and launch in Israel, because this is something we know we can do, it doesn't matter COVID or not. And what we're doing now is we're setting up a pilot factory here where I'm sitting now, next to our lab, that we will start manufacturing by ourselves meat for testing Israel. But soon after that, we're going to place a machine with our Israeli partner for distribution to restaurants, not retail at this point of time. Yep. So just making small batches, taking them to restaurants in Israel, of course, serving them to people, generating feedback, and repeating these cycles. And soon after that, also in 2 countries in Europe, that we have already established partnerships. First, only to restaurants. We are much more thinking now, scaling up to restaurant is quite big. So it's not something small. It's not like one restaurant every month. It's a lot of meat every day. And we need to generate this constant stream of professional feedback. And then we're going to expand more on these countries and later in other countries in Europe and then in Asia. But in Israel, it's happening quite soon. We even have these past few weeks, chefs coming to us and us going to chefs, doing some tasting for consumers here in the lab. Went really nice, by the way, surprisingly well, because we're telling people this product is not ready. Don't expect it to be 100% ready. And some people say, okay, stop talking, it's amazing. Some people say, the texture is not what I expected. It reminds me more of this and not that. I expected this to be more like that. But people that have been experimenting with plant-based meat, they never had a plant-based steak. There's no such thing.
Yes.
So we try to set the expectation. It's something new. It's something that you're going to need some creativity to understand what you're eating. And in many cases, it's a mistake because people tell us, okay, it's really tasty. It's really meat-like. Why isn't this in the restaurant already?
Wonderful.
Sorry, Lavi. Just a quick question. What is the cost like? Obviously, premium steak costs a certain amount in high-end restaurants, etc. So what is the equivalent cost of 3D printed steak?
Just like meat. We don't want to be cheaper than meat. We don't need to be more expensive than meat. And we have the potential in the future to reduce the cost. But currently, the cost is not an issue. Currently, is the price level is like meat, not more than that, not less than that.
Okay. I mean, that's I mean, so that is interesting because most people talk about sort of being higher priced off the gate, and then at scale they're going to reduce it. So I mean, I think that's an interesting observation and strategy going in. When you first started, I mean, you mentioned there was a 70-year-old company associated with. So is this something that this company funded you, or you're part of that company, or was this is this a venture-backed company that you Redefine Meat, or how did the financing of the company happen?
No, I worked in the past in other companies in similar fields. When we set out first for a few months, the little money I had went on the basic experiments and setting up the company. And then we started to raise small amounts of money, really small, from amazing angel investors in Israel.
Okay.
Angel investors in Israel are looking mostly for an interesting market and a team that they can believe. It's not about showing that you have a product or showing that you have working technology. It's more about a vision and the right team. And when we were ready, when we developed already the first machine, we had some proof of concept tasting. We served meat to hundreds of people. Then we raised our first financing round from two organizations. One is called CPT Capital. It's a venture investment structure that invests in only alternatives to proteins.
Okay.
They want to replace animals from the food system, take animals out, so invested in Beyond, Impossible, Memphis Meat, and also an Israeli venture capital company, Hanako Ventures, that are really investing in cutting-edge technologies in Israel.
And many people might not know, but Israel is a hotbed of sort of, I mean, it has, I think, the first vegan army, sort of, you can get, if you're a vegan, you can get boots that are not made of leather. I mean, yeah, it's, people don't realize around the world that, Israel is sort of at the cutting edge of, and there's a lot of people, Israelis, who have adopted a plant-based lifestyle. Am I correct?
Yeah, in Israel, for many strange reasons, not many know this, we have the biggest number of vegans and vegetarian per capita. And also a lot of the thought leadership around animals in the food system comes from Israel. A lot of the alternative meat companies are actually from Israel, and the largest, most successful plant-based meat company in history came from Israel. It's called Garden Gourmet. It's owned by Nestle.
Yeah,
still some of the best products in the world are from Tivol. And actually, in the 70s, you have people in Israel that said, let's bring people, a veggie schnitzel and a veggie burger, much before it was a trend. And still, they have amazing products.
So as Israeli, what is the motivation for that? I mean, in India, we know there's lots of vegetarians because there's a religious connotation to it. Is it a similar thing in Israel, or is it just something else that's at work?
There's many theories around that. I can't tell you that I believe all of them. And the Israeli religion, the Jewish religion, sees eating meat as like a necessary evil. It's something that we should feel sorry for and a little bit ashamed of. Also, we have the kosher laws that make eating meat very complicated. Mm-hmm. If you eat meat, my wife's family, for example, they never ate meat, just to make things simple, not to have two sets of dishes. And in the Israeli army, it's a wrong, it's not the, I was also a vegetarian in the Israeli army because the food is so terrible and you get terrible meat. When you say you're vegetarian, you get tivol frozen schnitzel, which is decent, it's this edible. But now we even have the head of the army is also a vegetarian.
Yes.
So you still in the army, we don't know. I don't know the real reason, but we do have the selection of options of eating plant-based food in Israel. It was always around. We have falafel. Falafel is chickpeas and bread. This is an amazing offering to somebody that doesn't eat meat. That's a part. Mediterranean food is has really, we eat a lot of vegetables, a lot of fruits. We eat tchina, sesame paste,
Yes.
which is now this is a mega food for vegans. But I think that innovation in technology in Israel is something that is also very strong.
Sure.
And if you combine all these reasons, there's a lot of good explanation why the innovation can come from Israel.
And I think, I mean, you mean even on the technology side, on the IT side, I mean, for a country that's small, I mean, you guys bat way beyond your weight. I mean, essentially, I mean, you produce a lot of amazing technology, you know, I mean, on the IT side, right? I mean, so there's that certain spirit, I think, of Israel that where innovation is concerned, that I think the whole world sort of envies. And I'm asking this question a little bit tongue in cheek because I know that, you know, Karthika is actually joining us from Sri Lanka. I'm Sri Lankan as well, but living elsewhere. I've always said, you know, we are a small island as well, and you know, we would, you know, I think a lot of people look to other countries, the Silicon Valley, for example, for inspiration on our technology side, and even on our food side. Now we seem to be looking at the countries much bigger than us. But I think Israel is a great example of a country that, you know, is small. I mean, population-wise, you're smaller than Sri Lanka with 20 million people. But you know, you've certainly, I mean, both in technology and now in food science, you know, you're just leading the way. That's just an amazing thing to see. Was the Israeli government, you know, any way helpful in are there incentives and programs for startups in food-based and plant-based and cell-based stuff? Is there a concrete effort?
Certainly, and it's also related. This is a reason that I know exactly why this is happening. In Israel, there is a culture of taking risks. This is embedded in the culture. Taking risk is thought of as a good thing. If you fail, it's okay, but you need to try. And the Israeli government supports that. When you have a new company, you need to show the Israeli government that you have challenges. If you tell them it's easy, I can do it, I have all the questions answered, they said we shouldn't help you. We should help areas that with risk. And we needed to convince them in two things. One, that we have technological challenge. And second, that this is a real technology. Because what was the problem? Food technology, there's a lot of amazing food technology companies. The Israeli government doesn't see this as technology. They say it's a new recipe. You cannot have a new patent if you develop a new recipe. So we needed to show that what we're doing can create a long-term sustainable advantage by technology. Once we show that, they really believe in food, they really believe in alternative protein, and they're besides the two venture capital companies that invested, the Israeli government is essentially the biggest investor. And what they want is they want us to hire engineers and to work on technology. They don't cover things like marketing or, you know, office space, but labs, experiments, hardware, ingredients. They're basically our partner, and they encourage us to take high risk than what we would normally take, because we can hire more people or we can work much faster, as long as we make sure that we develop intellectual property in Israel. It's very important to them. And the long-term approach is that this creates more jobs, our advantage in Israel is technology. We don't have natural resources. We have some gas, but not natural resources. We don't have a lot of land. And it's very hard to import and export from Israel if it's physical things, but technology can become really big in Israel.
So I attended, I think last year around October, where there was a Good Food Institute had a smart protein summit here, and the Israeli ambassador was one of the keynote speakers, and he came and he spoke to us, and he won a lot of, he was encouraging Indian companies to collaborate with Israeli companies, because I mean, India, we have the market, right? And you know, we are not constrained by the market, it's the technology and maybe the know-how. So he was trying to encourage Indian businesses to look at Israeli companies in the smart protein space to collaborate with. So clearly the Israeli government takes this very seriously, and it seems to have, obviously the diplomatic arm of the Israeli government has that as an agenda item, which is, you know, great to see. I mean, it's something that lots of countries should probably to also do. Yeah, Karthika?
Yeah, Eshchar, I was just funny. When I was doing my research, I found that there is a vegan community or a little town in Israel that has been vegan for 50 years. Is that correct?
Kibbutz.
Yeah, there are two. The one in the south and one in the north. Also, we have in the ultra-Orthodox world in Israel some people that embrace veganism completely, and it's related mostly to compassion for animals.
Okay.
For animals.
So, Karthik, I think we have some questions from
also,
our
where
audience.
I grew up in a kibbutz, have like a communal. Yeah?
Yeah, you grew up in a kibbutz? I heard that.
Yeah, we had some glitch. Yeah, so
yeah, there was a little bit of a thing on your end, I think. Yes, go ahead.
We have a lot of communities that are very close to veganism or completely vegan because of that reason. Connection to animals, working with animals, animals mostly.
Great. Karthika, do we have some questions from the audience as well?
Yes, we do. One question came in from Ritu Chatwal. Thank you for joining us today. Which countries in Europe will you first start distributing once COVID clears and you have some idea of how the market is going to play out?
Yeah, we already know because we've been working with some partners in these countries before COVID and even during COVID. It's after Israel, Switzerland, and Germany.
Okay. We have a question from Mohan. He's asked a whole bunch of questions, but I'll do a specific one. Is that essentially what he's asking? So would you price it as a multiple of the price of a cow? And I think you've sort of answered it, but I think you can address Mohan's question directly.
And the prices of meat vary across the world dramatically. And we believe, besides some countries that meat is extremely cheap, we can be priced exactly like the equivalent part from a cow. Not more than that, not less than that, but if you eat a steak, our alternative to a steak will be priced roughly the same.
Okay. Right. And one popular question is whether you've tried printing Kobe beef.
Yeah, actually, Kobe is one Wagyu beef, and it has visible high concentration of fat. And when you look at Wagyu beef, it looks like something a machine made. It's a little bit too designed and too repetitive to be organic, but it is organic. It is a challenge because when you increase the amount of fat in Kobe beef, you can have 45% fat. It's really, first, it's difficult to taste. It's hard to eat more than 100 grams. And also it changes a little bit the texture because a lot of the texture comes from fat and our fat is different. But of course, from demonstration purposes, some of the things we do look more like Wagyu beef. Wagyu is Japanese beef and Kobe is one city where they make it.
Yes. Yes.
And we have another question from Gary Thomas. Thanks for joining us today. Will your product become available for franchise?
We don't see it as franchise. We see that some part of the supply chain, like local distribution, should be done with partners. You know, we don't have any advantage in having trucks taking our meat from the distribution center to restaurants, but it's not franchising. It's not like we start a 3D printed technology company that is going to have restaurants or going to have direct to consumer distribution. Because again, we're really focusing on the problem. The problem is how meat is made and what is the supply chain, not the last mile of how you're going to get it. And we are working with partners, but they are big established food or meat distribution companies that are usually have been around for many, many years and have a strong presence in a specific market that we cannot have or we don't want to have.
What you've done is essentially taken the cow, the abattoir, the processing plant, and wrapped it all up in a refrigerator.
Exactly, and then you have everything without all of these steps.
Right.
What comes out of the machine is like meat, but the biggest steps, the biggest waste, the biggest time, the biggest pollution happens there. And then you basically need to deliver it to the restaurant and cook it and serve it. Exactly. You said it really nicely. I need to write it down.
I'll send you the recording.
We'll send you the clip. Now, a popular question from our audience is when will they be able to get this in the supermarket?
It depends where around the world, but the supermarket is 2 years at least, because when you go to the supermarket, you need two things. First, massive scale. You cannot go to even Switzerland or Israel and not be in every supermarket. It creates a huge disappointment. And also it needs to be more clear to the consumer what this is. And when you go to a restaurant, you eat something, it's tasty, you eat it again, it's tasty. Then in the third, fourth iteration, to cook it in your home makes sense. If you just see it for the first time and you try to cook it and you don't understand what is this product, remember, introducing it's a new food product. Okay, it's not a new version of a product. It's something quite complicated, and you need to do it in the right way. And we're not looking for massive scale now. So long-term, the potential is retail. Short-term, it will be really not a headache, but it will be a wrong way to spend our efforts and the focus. But I don't see a reason for this not to be in every supermarket around the world in a few years, because the potential is there in every country. You know, some people say India, local consumption of beef in India is smaller than in other countries, but still it's a massive market even in India, you know, and you go to China, people in China consume more pork, but the increasing consumption of beef. So there is no country around the world that don't have this need. The problem is big and the economical potential is big. So scaling up or expansion are almost not the question. It's quality and focus of a company on what we want to achieve short term.
So I see the distributed manufacturing paradigm work in terms of sort of getting the 3D printing machine to various locations all over the world from maybe a handful of manufacturing units. What about the source raw material, right? So are you seeing yourself currently sourcing that from multiple people, but how do you maintain sort of consistency, quality across the board, making sure that, you know, these materials, I think you said shelf stable. So how do you make sure that, you know, doesn't sort of get disrupted? And what is that component? I mean, to make in that, you know, how much of storage is required to get the raw material in there? I'm assuming if you're making 100 kilograms of meat, you probably need at least 100 kilograms of raw material.
It's an excellent question and one of the most challenging things in food. Just the last sentence, this is where the secret lies. When you look at meat, when you look at plant-based meat, actually it's 60 to 70% water. And when you take out water, you don't need 100 kilo to make 100 kilo, you need 30 kilos. And these 30 kilos are powders that are commoditized and have extremely efficient distribution around the world. Once you introduce, in all food, not only in our product, once you introduce water, then the challenges happen. And essentially what we want to do, first, the production of cartridges of our ingredient is centralized. This cannot be distributed.
Great.
But this is extremely efficient. It's things that are commoditized, are shipped across the world, they can come by boat. And eventually we can also make one factory in Asia and one factory in the USA, not to ship powders all over the world. But taking out the water from plant-based meat is the key to unlock distributive manufacturing. And then what you have is very easy to transport, very efficient, much less pollution in the supply chain. You don't need to think about shelf life so much. You don't need to have a cold supply chain. And it can sit until you manufacture. Okay, and if you didn't manufacture, it didn't happen. You don't have meat. If you manufacture, then you have meat. And you can build a totally different way to approach it. Luckily for us, in what we're doing, proteins, fats, you have giant conglomerates that are hundreds of billions of dollars just doing that, just doing supply chain. And it's very similar to pharmaceuticals. And this is actually quite a modern world. And again, it doesn't make sense to do it from Israel, but you don't need to start by having a local production in each country to avoid that.
Wonderful. And that explains sort of your price competitiveness, right? Because you just took 70% of your shipping weight down. You took out the cold chain completely out, right? You decentralized your manufacturing by doing distributed. So yes, so now you're competitive because essentially, you know, you're transporting 30 kilograms to make 100, and the water comes at source. Brilliant.
And the biggest part that you missed is waste. Once you have the normal, even the meat, with all the waste that we have in meat production, the meat that reaches the supermarket, between 10 to 12% goes to waste. So imagine going through all of this hassle, growing up the cow, feeding it, pollution, all of that, processing, abattoir, everything that you mentioned, then it's already in the supermarket. 10% goes to waste. It's terrible.
Wow. So, I mean, I can see why this is a revolution, right? As opposed to this is not an evolutionary process. What you're talking about is a radical transformation of how a steak gets to your plate. I mean, it is a whole new paradigm. It's not, it's using a lot of these sort of cutting edge processes as well as innovations in technology and manufacturing and science, of course. Brilliant.
It's how the meat industry should look like in the 21st century. Why does it can happen in every other industry and not the meat industry?
So we learned this week that KFC is using 3D printed, cell-based chicken nuggets are going to come on. How is that technology, I mean, other than the fact that they're using cell-based, radically different from what you're doing?
First, I don't know about what they're doing besides the fact that they say cell-based and 3D printing. There's a lot of strategies that you can go about with what you're doing, and all of them make sense. It's only a matter of timeline. We think that for the coming few years, 3, 5, 7, plant-based meat has a massive potential because it's there. You can eat it, you can improve it, it's approved by regulation. We don't take out of the consideration that 7 years from now you have other alternatives. And we're certainly happy to see many more companies going into this field. Eventually, there will be an ecosystem. One company cannot do everything. We do the formulations, the machine, the software, but we don't do ingredients. If somebody can develop cell lines for us and we 3D print them 7 years from now, it makes sense. And you look at this industry, you look at everything that we're doing from investment perspective, amount of companies and R&D, it's tiny. Every other industry that you can imagine that is important has between 10 to 1,000 times more than that. So a handful of companies working on 3D printing, we love to learn from them what they discover doing chicken. We're not doing chicken. Maybe they will have some revelation that is relevant for us. Maybe we can help them because we know what is needed to make a better texture and how to scale up the machine. And 5 years from now, we'll work together or we'll be competitors, but then we will each bring something interesting and important to the market.
Well, on that note, any more last questions, Karthika? Because we're right on the hour. I want to make sure.
Final one, Lavi, is essentially what the audience wants to know is, so you're using soy and pea, and soy kind of gets a bad rap, because scientists don't think it's very good for health and stuff like that. So how are you planning to address that sort of issue?
So first, scientists think that soy is really good for health. Consumers have some challenges with soy in some places around the world. From a nutritional perspective, soy is probably the best plant-based protein that we can get. And if you don't want to eat alternative to meat because soy is bad for you, then you're not a part of the consumers. You can eat lentils and you can eat pea protein, but we're dealing with people that eat meat, and definitely eating less meat and eating more soy will improve health. So from that perspective, we're very confident that we have a good solution. But actually soy, what's very funny? Soy has a bad reputation around the world because soy is consumed in a lot of the rainforest land, but this is soy to feed cows.
Yeah.
Actually, many people that are against soy in plant-based meat because of the perception that soy is bad for the planet because it's mostly used to eat cows. And listen, we want people that eat our soy instead of meat, and other people around the world will have more food to eat, and it improves health and improves the sustainability of the planet. And I eat soy. I know people that don't eat soy because they think it has estrogen, which is known not to be true, but we cannot win all of the battles. We have a lot of challenges. We have a lot of difficulties to face. We need to have a really tasty product in a reasonable cost that doesn't come from an animal and is sustainable. And in the next 2 years, we can remove soy, we can remove allergens, we can improve the nutritional composition, et cetera, et cetera. We cannot do everything. We're doing a lot and we're achieving a lot, but we are not solving all of the problems.
Well, on that note, Esh, I mean, it's been I didn't realize how the time was flying. I'm sure you were hopefully equally enthused about our questions. So thank you so much. I mean, I think I've learned a ton. Karthik, I hope I speak for you as well.
We just got some feedback saying what an erudite guest we just had.
Okay, well, there you go. It's certainly an erudite guest.
I don't know what is erudite. I need to look it up. I hope it's a good thing and not a bad thing.
It is a very good thing.
Thank you. Thank you very much. I enjoyed it. And if somebody wants to, in the website, you can write info. You'll get the answers from me directly. Very approachable, and stay tuned for more news from us.
Well, certainly, and hopefully this crisis that we are under eases up eventually, and we can make it to Israel or Germany or Switzerland and taste one of these steaks. I'm a vegan as well, and Karthika is a vegetarian /vegan as well. So we'll definitely want to try that.
I'll tell you, when we are able to fly on the business level, I'll go to Switzerland. On the personal level, I'll go to Delhi. That's my first trip.
You can be an honored guest. We'd love to have you, host you, not a problem. And I'm sure we can have a big of a fan-based meeting here. I'm sure there'll be a lot of people curious to learn what you do. So yeah.
Thank you very much.
Thank you so much, Esh. Thanks, Kartika. And we'll see you soon.
Bye.
Bye.
Bye.